Okay, guys, this may not be the best, but I am I'm at the PetSmart, getting my dog groomed in my car in the parking lot. So this video is not going to be a 10 out of 10. Not like the others are, but still. Okay, so atom structure. There is going to be a problem on your test today about atom structure. So let's answer this question and see what questions we can pull out of it. Which of the following statements is true about the structure of the atom? Neutrons and protons have approximately the same mass. That is correct. Neutrons weigh about the same amount as protons. Neutrons and electrons have approximately the same mass. Neutrons are greater in mass than electrons. Electrons are teeny tiny. Protons and electrons have the same charge. That is not true. We know protons have a positive charge and electrons have a negative charge. Protons and neutrons have the same charge. Again, not true. Neutrons are neutral. Okay, so let's see some things that we can pull out from there. I would say protons are the same for each element. Neutrons. Why am I spelling so bad today? Neutrons give isotopes. And I guess electrons tell the charge. And specifically, valence electrons are for bonding. Binding, same thing. Okay, so that is it for that question. You will have one question on your test about that. Functional relationships is the next one. So, let's look at the equations first. It says, which of the following is an incorrect match between an equation and a functional relationship? So we'll make sure what equations we have. We have linear. We have inverse right here. We have not even inverse square, but inverse. And then we have exponential. Okay? So linear is going to give you that proportional relationship. Inverse is an inverse relationship. This is an inverse. And it says it contains an inverse square, which is not true. It's just an inverse. For it to be inverse square, it would have to be y equals m over x squared plus b. Okay, x has to be on the bottom, making it inverse, and then squared. And then exponential, which is correct. So the one that is incorrect is this one. So let's talk a little bit about that. When you have a proportional relationship, you're going to increase as much as you did with y. So if we go from 1 to 1, and you'll have 2 to 2, these are coordinates, and then 3 to 3, and so on. So your line should look like this for linear. For inverse, if you have a 1, you're going to have a 1 for y. If you have a 2, you're going to have 1 over 2 squared, which gives you 1/4. If you have a 3, you're going to have 1 over 3 squared, which gives you 1/9, and so on. Oops, we did that for the wrong equation. That was inverse square right here. I skipped inverse. So now we have inverse, which is 1 over 1, 2, and the y would be 1 over 2. 3, and then the y would be 1 over 3. And then 4, and then the y would be 1 over 4. Okay, this is inverse. Inverse squared on the bottom. And then the top one was inverse. Okay? An exponential, you're probably not going to see an example like that. What is scientific notation? Math. So we've talked a lot about this. You will have one problem like this. Okay, so in this case we have 3 times 10 to the 8th over 3 times 10 to the negative 7. Remember, when you divide, you do the number first, so 3 divided by 3, you're going to get 1 times 10. When you divide, you're going to minus them. So let's pull these out. 8 minus negative 7. So that means we're going to add, because it's a double negative, 8 plus 7. That is 15. 1 times 10 to the 15. So let's do a multiplication one now. 3 times 10 to the 8 multiplied by 3 times 10 to the 7. So once again, do your numbers first. 9, 3 times 3 is 9. Okay, pull out these. You're going to do 8 plus 7 since we're multiplying. When we multiply, our exponents get added. 8 plus 7 is 15. 9 times 10 to the 15. Okay? And then obviously our answer for the first part would be this one. And then this one. Okay? So this is pretty easy as well. Approximations. So the more you have to round, again, there will be one question like this. The more you have to round, equals the more error you get. Okay? So, moving on from that part. It says, what's the following elements would introduce the most error if you rounded to the integer value for atomic mass in a calculation of molar mass? So that basically just says to put in whole numbers. Okay, so let's look at the elements. We have carbon, we have nitrogen, we have oxygen, we have fluorine. Let me pull up my periodic table. says that carbon is 12.011. Nitrogen is 14.007. Oxygen is 15.999. And fluorine is 18.998. Okay, so this one is asking, which one do you have to round the most? Which one will give you the most error? Okay, so let's look at this. This one we only have to round to, we round to 19 here. And this one only changes by 0.002. We'll round to 16 here, and it only changes by 0.001. We have to round to 14 here, and it only changes to by 0.007. We have to round to 12 here, and it changes by 0.011. Okay? So the one that changed the most is this one, which is carbon. The more rounding, the more error. Which of the following values for energy is in MKS units? So energy is going to be joules. Okay, let's go over the other MKS units. I have a feeling it's the one that's not loading. Oh, no. Okay. MKS units. So for length, we have, let me just copy and paste this. Copy. See if I could paste this onto this. No, I cannot. Okay, so let's just go over it. Length, MKS units will be meters. Time, we have seconds. For mass, we're always going to use kilograms. For energy, we're going to use joules. For temperature, Kelvin. For matter, moles. And electric current is amps. So please remember those. I'm going to screenshot it and send it in our group